So for this problem, we are tasked to find the force P required to turn the wheel over the block given that the weight of the wheel is 500 newtons. And if P will be inclined at an angle phi, find phi so that P is minimum. So to solve the first problem, let's draw a free body diagram of the wheel. So the wheel has a radius of 25 centimeters and it has a weight of 500 newtons. And the other forces that acts on the wheel is force P and a reaction due to the block that is normal to the surface of the wheel. Let's call this force N. Now what we are missing is the angle between the weight and the normal force. Now to solve this, let's make use of the geometry of the entire figure. Now we know that the radius is equal to 25 centimeters. So to find the angle, we construct a triangle. Knowing that the height is 10 centimeters, therefore, the height of the triangle is equal to 15 centimeters. Now given we have the hypotenuse and the adjacent side of the triangle, we're going to make use of the cosine function to solve for the angle theta. So that is cosine theta is equal to adjacent, that is 15, divided by hypotenuse 25. So theta is equal to r cos of 15 divided by 25, that is equal to 53.13 degrees. And let's copy that to our previous slide. So to solve for force P, we can make use of the equations of equilibrium, that is summation force x and summation force y. So taking summation force horizontal to solve for n, we have negative 500 newtons plus force n. Instead of representing this as n, let's call this force F, so that we don't confuse for newtons and force n. So this is negative 500 newtons plus force F cosine of theta, that is 53.13 degrees, equal to 0. So force F is equal to we get 833.33 newtons. And to solve for force P, we take summation of force horizontal. It is equal to P minus F sine of theta, that is 53.13 degrees, equal to 0. Since we have the value of F, we substitute it into this equation. 833.33 newtons times sine of 53.13 equal to 0, and we can solve for the value of P. That is 666.66 newtons. So that's the answer for the first problem. Now for the second problem, if P will be inclined at an angle of theta, find theta so that P is minimum. So it is asking us for the value of the angle theta for P so that the resultant force would be minimum. So let's call this angle phi. Now to solve for the angle phi, in order for the resultant to be minimum, the force P and the angle between the normal force F should be perpendicular. The reason for this is because when these forces act at a 90-degree angle to each other, they do not directly reinforce or oppose each other, leading to a smallest possible combined force resultant compared to any other angle between them. So knowing that this angle here is equal to 53.13, and this angle here for P between P and F, that is 90 degrees, Therefore, the total sum of this angle is equal to 90 plus 53.13 degrees. That is equal to 143.13 degrees. And to solve for the angle between force P and the horizontal, we subtract this overall angle with 90-degree angle. So subtracting 143.13 degrees minus 90 degrees, we get 53.13 degrees. And that is the answer for the second problem.